And as we have understood, the Singapore Basin is a massive opportunity for electrification, both in terms of the vessels and the harbor equipment, but also to support the grid. Let's see if I'm able to present here. I'm not allowed to present, I think.
Yes, there. You have to help.
Yeah, I'm on it again. So there we are.
Thank you.
There we are. Thank you.
Yeah, so just let me know when to click.
Yeah, so this is Hagal. You can click to the next one. So big things are happening in Glasgow this week, and we claim that 80% of the world's energy has to, let me see if I can remain on the presentation. Energy consumption has to move from fossil to renewable energy. This is the big thing. And subsequently, the grid is not able to handle this transition today. So we need local energy storage, and we're talking batteries. You can move to the next one, Peter. So Hagal, this is what we do. What we claim is that we increase the efficiency of the cells and the battery packs with our Rebel Core technology. And we extend the lifetime, and we claim that we can use lower quality cells and also reuse of EV cells. So the big market is really for electrical vehicles. But in Norway, the big market is now in marine packaging and also shore charging. But in the bigger world, and we're going to the east and also to the west, especially in California, the big battery parks are where all the megawatt hours is going in. And it is very important from an economic standpoint that the battery packs last for as long as possible, not only from an economic point of view, but also from a CO2 footprint point of view. So being able to use reuse of EV batteries, we claim is important for the future. So we do this with a very unique technology. So we include hardware on each battery cell and control the energy from each battery cell. We need some machine learning to be able to do this on a big scale. But most importantly here is that we are chemistry agnostic. So that means NMC, LFP, NCA, and what comes in the years are chemistries we will be able to handle. So we're rolling out the Rebel Core technology internationally in 2023. Next one, please, Per. So again, Rebel Core technology is a hardware component that connects each battery cell, and it's multifunctional. We have frequency and voltage regulation, peak shaving, transmission, distribution, and energy storage as a total. What we do is that we replace the three systems you have in a battery pack on top of the cells, the battery management system, the inverter, and the charger with one combined unit. And to do this, we have hardware in the sense of PCBAs and firmware, and we have extensive use of algorithms with cell level control. And the modulation is both high current and high voltage. And we have already deployed a little bit of the technology, and 2022 will become very important for us for larger systems. Next one, please. So this is the battery landscape as we see it. So moving from left, battery passport is something which is being talked a lot about these days, both from a CO2 footprint and traceability point of view, also from birth to grave. So this is important. Footprint on CO2, but also in regards to safety, as lithium-ion batteries does present a fire hazard. Logistics is important. Batteries are heavy. Most batteries are made in the Eastern Hemisphere, and they have to come to Europe, and they have to come to the US. So having good supply chains is a key. Electronics R&D is important for the future, and Hagal, we are extensively using electronics to control the batteries. There has to be more module and pack assembly in the Western Hemisphere to compete with the East, and having the services on installation and on site is extremely important. So these are elements we are building up now. More to the right, this is where the big industry is going. Software to control the battery parks, control the vessels in a bigger sense, storing the data and doing analytics. So this is where we see the big players are going, and this is also where Hagal is going. The next one, please. So on the product side, so as far as we are now developing the core technology and rolling that out within the next 1 to 2 years, we have also taken the opportunity to present some more normal technology in that sense. So we have developed a land-based module, and we have developed a marine module. And on the right, we have the marine module. That's based upon iron phosphate battery chemistry, LFP. And if you go to the next slide. Yeah, so this shows the module itself. It's 176 kilowatt hour divided into 3 modules, giving 760 volts. And we have deployed this in sea farms in Norway, and we see a great opportunity for this technology and this chemistry in regards to safety. The next one, please. So we delivered a battery energy system, this package here, both for propulsion and for storage systems that can be used onshore, offshore, and subsurface. The pack is IP67, and it has been tested by DNV for type approval. And it can be combined in several units to give larger systems. I think also it is important from a marketing point of view is that when we sell these systems, we also want to attract clients that is willing to give back the units when they see them out of service, such that we can reuse the batteries. This is a big issue for us, and this is what we are marketing when we go out and talk about reuse of batteries. The next one, please. So this system here is still the LFP package. We see from the chart in the right-hand corner that the LFP chemistry is not the most energy dense system, but it is quite good on specific power. And this system here is designed to give what we call the 1C. So that means we can kick it up to about 160 kilowatt on continuous power. It's high safety and high lifespan. We expect more than 5,000 cycles on a pack like this. And it has been designed with less connections and integrations, meaning that you can lower it down into vessels, into the machine room, and for the integrators, very easily adapt this to the propulsion system, both in hybrid applications, but also for pure electrification of the propulsion, but also for the ancillaries. The pack offers also integrated fire suppression and BMS, meaning that everything is enclosed, meaning that we do not expect any problems whatsoever in regards to safety for fire, for instance. The DNV type approval is pending. For the sea farms, it is not DNV type approval required, but we are expecting the certificate to be in the mail in the next coming days. Thank you. Next, please, Per. So this is the inside of the pack. As I said, it's an IP67 unit, so it's absolutely tight, watertight. So we see the modules inside, we see the series connections, and we combine this into 3 boxes. That's about it. Next, please. So we have talked about the LFP module. We also know that the market will look for more power dense solutions exceeding the 1C. So NMC is, of course, the next big thing. So we are developing now an NMC module, which we believe can be marketing from second quarter in 22. And then on the right-hand side, lithium titanate, which is a very different application and chemistry. It's very high C rates and very special applications, but we see it possibly for oil and gas applications on offshore. Thank you. Next. So this NMC pack, it's more for higher velocity vessels compared to the LFP module. But it will also be very relevant for grid buffering and for storage import for the charging applications. NMC has about 50 to 70% higher energy density than the LFP. So fast charging is a very good opportunity for NMC chemistry here. Thank you. Next. Yeah, so with that, I open up for questions.
Thank you, Fredrik. Yes, we have time for a few questions, I think. We're a bit on overtime, but we'll make the wrap-up short.
I have a quick one for you, Fredrik, and that's on, you said you're chemistry agnostic. Does that mean that you can construct packs that have different chemistry for different purposes, or doesn't that make sense?
It can make sense. Also, in a marine setting, it can make sense for planing hulls, for instance, in that you have one part of the package bringing you up to speed and on top of the water, and then you have a more lenient pack on 25% or 30% of the power for the longer duration and the longer distances. So that can have absolutely one application there. But the point with being agnostic on chemistry is that our core technology doesn't doesn't really care about what kind of precursor you have in the battery, you know. Yeah.
Right.
Thank you. Any more questions? Again, a very interesting presentation and very relevant. I think everybody's looking forward to getting some good solutions on the battery side. It's really nice technology, although certain limitations in weight, of course, per kilowatt. I think that's about it. I'll try to give some, from my side, a short summary, and without going into the technical presentations themselves, I tend to go back to this opportunity for cooperation. Singapore and Norway is quite similar. We have about the same population. We are extremely oriented towards the ocean. It's a very innovative society driven by technology in many senses, both Norway and Singapore. So there's a lot of commonalities here that can really be utilized in cooperation. But on the other side, I also think some of the differences are extremely interesting. For instance, Singapore has one big port. We have lots so small. It's a very nice complementarity. Singapore is extremely small in physical size. Norway is very long. And also, as was mentioned, the energy supply is very different. We have a lot of hydroelectric power, so we tend to look at all electricity as green, but that is not the case in Singapore. So again, we have a lot of commonalities which should make technical cooperation easy, and we have a lot of differences which really makes an interesting span in applications. So that's at least one very short takeaway from my side. So Alan, you have some final words?
Yes, and Norway is 500 times bigger than Singapore with the same population. But I think we decided we're 10,000 kilometers away from each other, but still find a lot of common themes to work on. And I think there's a shared culture, a mutual respect, and a kind of common approach to scientific thinking that is very helpful in aiding this collaboration to go forward. So for my part, I was very glad to be able to participate and help share this session with your Arnaf. And I look forward to some more interactions as we go forward with our partners in Sintef Ocean and other Norwegian entities in the future. And I think, you know, Ching-Peng Tan mentioned at the beginning that we should look for areas to collaborate and joint funding where both sides can benefit and share the outcomes. And I think that will help both sides take it further, given that we are both from small nations. Then it's good to combine forces and pull the wagon in the same direction. So with that, I will wrap up and hand back to Per Christer.
Thank you very much, Ørnulf and Alan, for a very good moderation or emceeing through this session. This is the last day of the Norway-Singapore Science Week. Touched into 3 other areas in this week as well. It's been quite busy and quite good. I'm really pleased, or we are really pleased. I'm talking on behalf of the embassy and the ambassador and the Innovation Norway to see that these agreements, the MOU, is continued. I think there is, as said, you kind of span out where we have complementarity. We are supplementary on many areas. So we are happy to be the facilitator to make these happen. On the research level, on academic level, but also on business level. So looking forward to an exciting time going forward. Cross fingers that we are able to have the next Science Week in physics or physically. And Alan, we will definitely come and jump in the pool.
Yes. Great. We're ready for you.
Yeah, definitely. So with that, I'd like to thank everyone, the speakers, the moderators, and also the participants for this session. And I wish you a very good weekend. Thank you.
Thanks, everyone.
Thank you. Bye.
Bye.
Thank you.